In this video, we'll look at the third type of equations from section 5, and that is solving equations containing rational exponents. Recall that the word rational means that a number can be written as the quotient of two integers, where the denominator is not 0, but in other words, we're really looking at fractional exponents. It's very important to remember the definitions of a fractional exponent or a rational exponent. X to the 1 over n is the same thing as the nth root of x. And x to the m divided by n is equivalent to the nth root of x to the m, or we can also write that as the nth root of x all raised to the m. These two definitions just change when you apply the exponent of m. Do you apply it before you take the root or after you take the root? Typically, it's easier to do it after the root. So let me remind you of some examples. Negative 8 to the 1/3 means to find the cube root of negative 8. The cube root of negative 8 means what number do I cube to get negative 8? And that is negative 2. The expression 16 to the 5/4 means to figure out what is the fourth root of 16 and then raise that to the 5. The fourth root of 16 means what number do I raise to the 4 to get 16? And that is 2, right? 2 to the 4 is 16. This therefore means to find 2 to the 5, which is 32. Okay, so just some remembrance of those. We'll come back to seeing these as we go through some solving equations. Now, how does this relate to what we've already learned? Well, we can actually write a radical equation as an equation containing fractional exponents. If I see the square root of x minus 3 minus 4 equals x, which is what we just solved in the previous objective, well, the square root of x minus 3 is the same thing as the quantity x minus 3 to the 1/2, then minus 4 equals x. Because x to the 1/2 is the square root of x. So the properties and solving techniques that we applied in this objective can apply here. We're going to have to isolate the expression with the exponent, and then we'll raise each side to the same power to eliminate the fractional exponent. So here are the steps to solve these equations. We'll isolate the expression with the rational exponent, as I just mentioned. Then we will raise each side of the equation equal to the reciprocal of the rational exponent. So our equation is going to be the form x to the m divided by n equals k. And then we're going to raise each side to the n divided by m, because remember that when we raise an exponential expression to another exponent, the rule is we multiply those exponents. And so when we multiply m over n times n over m, we just get 1. So this is how we'll obtain x on a side by itself equals to just some number. But the key actually lies in if the denominator of this outer exponent is odd or even. If it is odd, we will just have one solution of the equation. If it's even, we'll have two solutions. And I'll explain that as we go through. I did give you some explanation of this in the text as well. But the key is we want to isolate the expression with the rational exponent, raise each side to the reciprocal of that exponent, and then solve the resulting equation, and we can check possible solutions. So here are some examples. We have x to the 3/2 is equal to 8. To solve this equation, we need to raise each side of that equation to the reciprocal of 3/2, which is 2/3. Now, because the denominator of this exponent is odd, we will have just one solution. x to the 3/2 to the 2/3. The 3/2 times 2/3 is 1, so that just gives us x. 8 to the 2/3 means to find the cube root of 8 and then square it. The cube root of 8 is 2, and 2 squared is 4. So we can check. Is 4 to the 3/2 equal to 8? Well, 4 to the 3/2 means to find the square root of 4 and then cube. The square root of 4 is 2, and 2 cubed is equal to 8. So that checks. Therefore, the solution set is the set containing 4. Part B is x plus 2 to the 1/3 equals -5. The expression with the exponent is isolated. So we can raise each side to what power? Well, we need to raise it to the reciprocal of this rational exponent. The reciprocal of 1/3 is 3. So x plus 2 to the 1/2 to the 3rd. We multiply those exponents to get just 1. So this gives us just x plus 2 is equal to -5 cubed is -125. And subtract 2, and we get -127. And we can check our work. If we replace x with -127, we would get -127 plus 2 to the 1/3, and that is -125 to the 1/3, which means to find the cube root of -125, which is -5, so that checks. In part C, we have 5 to the x minus 2 to the 2/5 is equal to 80. We need to isolate this expression with the exponent, and we can do that by dividing each side by 5. We get x minus 2 to the 2/5 is equal to 16. Now we need to raise each side to the exponent, that is the reciprocal of 2/5, and the reciprocal of 2/5 is 5/2. But when we take this exponent, notice that the denominator is even, so that tells us we're going to have two solutions of positive or negative. And I'll show you why that comes into play in just a minute. So on the left, x minus 2 to the 2/5 to the 5/2, multiply those exponents. 2/5 times 5/2 is 1, so that just gives us x minus 2 on the left. And then this is equal to plus or minus 16 to the 5/2 means to find the square root of 16 to the 5. So we get x minus 2 is equal to plus or minus 4 to the 5. But 4 to the 5, if you do that on your calculator, is 1024. We set then x minus 2 equal to positive 1024, or x minus 2 is equal to negative 1024. So we add 2 to each side to get 1026, or negative 1022. And the reason we get two solutions is because when we substitute these values back in, we'll just check. Let's check with the negative 1024. I would have 5 times negative 1000, check with the negative 1022. 5 times negative 1022 minus 2 to the 2/5. And we want to find out, is this equal to 80? Well, so this becomes 5 times negative 1024 to the 2/5. But this means to find the 5th root of negative 1024 and then raise it to the 2. The 5th root of a negative number is negative, so this is -4, but then we can square it to get 5 times positive 16, and that's why we have two solutions, because when we did the reciprocal and the denominator was even, that meant that the numerator of the original one was even. And so after we take the root and raise it to an even number, we get a positive value. And there are two values, the positive and negative, that can give you the same squared result. And that's why we have to have a plus or minus when the denominator of the power we're raising this to is even. So our solution set would be negative 1022 and 1026. And then in the last sample, we have x minus 6 to the 3 halves minus 4 equals 60. We need to isolate by adding 4 to get x minus 6 to the 3 halves is equal to 64. And now we want to raise each side to the reciprocal of 3 halves, which is 2/3. And that denominator is odd, so we're just going to have one solution. On the left, we're just left with x minus 6, right, because those exponents multiply to be 1. And then 64 to the 2/3 means to find the cube root of 64 and then square it. The cube root of 64 is 4, right? 4 cubed is 64, so 4 squared is 16. Our equation then is x minus 6 equals 16, and we can add 6 to each side to get 22. And then we can plug that in and check if we want, but the solution set contains only 22.